Hi, you're listening to Avril Salter talking about CCNA Wireless. Now, in this lesson, we're going to focus in on the different access points that Cisco manufacture and provide for different enterprise environments. You know, one of the lovely things I like about Cisco is its background and its origins. So Cisco was actually formed by a married couple, Sandy and Len Bozak, and they used to work in two different departments within Stanford University, and they were having problems getting their computers to communicate with each other. And so at home they actually developed a gateway server that then could help them connect these two computers using the IP protocol. And it was actually that product that started the formation of Cisco and became their first commercial gateway server. And of course is now being led by John Chambers, who's been in that role since 1995. And John Chambers has really led the organization through some amazing growth periods with quite a few acquisitions to bring it to its current position. So I mentioned that under John Chambers, Cisco made several acquisitions in order to grow the organization. On this slide, we're looking at the acquisitions that were made that were around the wireless LAN area. This acquisition actually enabled Cisco to enter the wireless LAN market, and they did that with what was called the AirNet 340 series. It's going back a bit to year 2000. It was about a year after that they made their second acquisition, Radiata, and this gave them an 802.11a wireless engine. And it's important to remember here that the 802.11 standards A and B were only finalized in 1999. So this is right on the crest of people developing product for those two standards. Cisco finished their acquisition of Airspace. Airspace had quite a wide variety of products, but they included wireless LAN controllers, location software, intrusion detection systems. So it really gave a very broad set of products to Cisco, including of course access points. And this product line really filled in the middle because they had Linksys, which would provide their low end, and then they had their Cisco FAT access points from AirNet, and these Airspace products really filled in that middle market. Then in 2007 you see them acquiring Cognio. This is an amazing company that was really strong in the wireless spectrum analysis, and this formed the basis for Cisco's product called the Spectrum Expert, which you use when you're doing a layer 1 site survey, and it also was now been integrated into Cisco's high-end access points and referred to as Clean Air. So quite a lineup of wireless acquisitions. So let's talk for a bit about what Cisco means by the unified wireless network and what some of the intention was about Cisco pulling all of their products together. So the wireless network over several years has evolved and has now got several features like enhanced security, the ability to locate devices and equipment through tagging, is extended away from the origins of just doing wireless data to now doing voice and rich multimedia services. It also provides a range of different access methods. So not only can employees communicate, but it also handles things like guest access as well. Cisco's unified wireless network includes both what's referred to as standalone autonomous access points as well as lightweight access points, where lightweight access points are dependent on a central wireless LAN controller. And that allows the configuration to be pushed out to the access point, and so it allows you to centrally manage your access points from a central location. part of the Cisco Unified Wireless Network is also the Cisco Wireless Control System, which again is focused on the monitoring and manageability of your wireless network. I just mentioned the different mobility services and the ability to bring this together, and then of course bringing together the wired and the wireless security aspect. And of course the security is incredibly important as you're seeing more and more access points being connected to the network. In fact, a recent Cisco report said that in the future we're going to see over 60% of our traffic going over our wireless networks in the enterprise environment. So security and the integration between wireline and wireless becomes increasingly important. So let's go on now and talk about the Cisco access points, and I want to focus initially on the legacy equipment, and then after that I'll talk about 802.11n access points. Most of the legacy equipment, like here I'm showing the Ironet 1130 series, can operate in both a standalone autonomous mode or in a lightweight mode. The newer access points operate in just a lightweight mode, so do always check when you're buying your access point if you need it in an autonomous standalone mode or whether you need it in a lightweight mode or whether you need a combination. The Ironet 1130 supports a dual mode 802.11 ABG. It also supports inline power over Ethernet. It conforms to the 802.11i security specs, and so you can get WPA, and of course in the enterprise environment you should be deploying WPA2. So the 1130 has internal antennas. If you need the flexibility of using external antennas, then this is a product that used to be widely deployed, the 1240. Just like the 1130, it supports dual radio and also power over Ethernet. This one can be installed using an outside housing if you need to use it in environments that are more severe, such as outdoors, factory floor where it may experience a lot of dust and other exposures. I've quite often seen this one actually deployed in the ceiling, and then they're run down external antennas which then hung from the ceiling or maybe disguised somewhere. So it gives you a little bit more flexibility, as I mentioned, because of the external antennas. So I've mentioned a few times the autonomous and the lightweight modes of operation. Let's go through that in a little bit more detail. The autonomous one is really configured and managed, and you'll maintain it completely in isolation from the other access points that exist in the network. So you'll go in there and you'll completely configure it independent from anything else. When you're ordering an access point, you can actually look by the part number, and the part number will actually tell you whether you're ordering an autonomous or a lightweight mode access point. And so you'll see the prefix AP if it's operating in autonomous mode, and the prefix LAP if you're operating in a lightweight mode. A lot of access points, including the two we just talked about, you can go between the autonomous mode and the lightweight mode. You just have to reload a different piece of software. What is perhaps more common is that a smaller business will deploy an autonomous access point, and later on down the road, if they grow or find the manageability of autonomous access points to be problematic, they'll introduce a wireless controller, and then you'll need to change it to go into a lightweight mode. So in a lightweight mode of operations, your access point is really just becoming an antenna. It just receives the radio signal, demodulates it and decodes it, and then it puts everything back to the wireless LAN controller. And the wireless controller then makes all the decisions. Now in a lightweight mode, then the wireless LAN controller is making decisions, that means there needs to be a protocol that's going between the access point and the wireless LAN controller to help the wireless LAN controller manage and configure that access point. And that protocol is called the Lightweight Access Point Protocol, which is the older specification, or is called CAPWAP. And that stands for Control and Provisioning of Wireless Access Points, CAPWAP. And we're going to talk more about those protocols a little bit later on. So let's now talk about our 802.11n access points. Now the Aranet 600 series is really focused on the home teleworking environment, and so they called it the Office Extend access point. And the reason they called it Office Extend is because when people are working at home away from the corporate headquarters, they still need to connect into the corporation. And so this allows the CAPWAP protocol that I mentioned earlier to be configured and to interwork between this access point and the corporate network. So in this way, I can extend my corporate policies for my wireless connectivity out to people's homes. It also simultaneously supports the ability to have your personal network and your personal traffic separated. It supports a 2x2 MIMO, so 2 antennas for transmitting, 2 antennas for receiving. And if you're able to deploy with a 40 megahertz channel, then you can get up to 300 megabits per second in good RF conditions. And as I mentioned, is the Office Extend, so it supports a secure tunnel back to the corporate network. Our next access point to look at is the Aranet 1040. This is a great access point for deploying in smaller enterprises, maybe a branch location. It has internal antennas and is capable of supporting PoE, so Power over Ethernet. Also operates in autonomous or a lightweight mode of operation. It also supports radio resource management, which is a technique for predicting RF dead spots and taking action to resolve those dead spots to ensure that you can connect, i.e. improving your availability of the wireless LAN. So radio resource management is a feature of the wireless LAN controller. And I want to talk about it now because it kind of breaks up talking about all the access points one after the other. But it also kind of gives you a bit of an advantage of why you want to operate in a lightweight mode of operation. So the radio resource manager is effectively an algorithm that adjusts the settings on the access point, and the two settings that it adjusts are the channel that is operating on, i.e. the frequency channel, and the power setting. Let's say you're operating in the 5 gigahertz band and there is a considerable amount of interference. Then the wireless LAN controller can say, you know what, access point, I'm going to move you off channel 36 and I'm going to assign you to channel 48, because if you move to channel 48 you will suffer less interference and therefore the performance will be better. It can also adjust the power level. So say for instance it's saying, oh, I've got a high amount of interference. What I might want to do is slightly increase the power level such that it improves the coverage and the ability for clients to successfully communicate with the access point. On the other hand, it may say, hey, you're interfering more than you should with this adjoining access point which is operating on the same frequency, and therefore I want to reduce your power level a little bit. And so it's able to adjust your channel and your power levels depending on your RF environment. So basically what happens is the access points will gather information about what's happening in the RF environment, feed it back to the wireless LAN controller, which will run these algorithms, which will then decide how best to manage these access points and then push that information and change the access point settings. So let's go on now and talk about the 1140 series. It's very similar to the 1040, gets up to 300 megabits per second, it supports a dual mode radio, supports legacy equipment as well as the new 802.11n, operates in a lightweight and an autonomous mode. The difference is that this is a 2x3 MIMO, whereas the 1040 was a 2x2 MIMO. 2x3 MIMO means that 2 antennas for transmitting, 3 antennas for receiving. So what that means is that it's going to be better at receiving signals from clients. So for instance, if you had voice devices which tend to operate at a lower power level in order to conserve battery power, then what you'd find is that this access point may have better ability to receive those signals. And it's interesting because whenever you define and design your network, even though these access points look similar, the antennas are different and therefore the coverage is going to be different. So always remember that you design your network based on the access points that you're thinking of acquiring. And this is a great example of that. So now let's look at the Aranet 1250. The advantage of this one is that it operates in a more challenging RF environment. And what do I mean by that? You know, environments such as factories, warehouses, industrial environments where you need a more rugged metal housing. It operates at extended temperatures. So not in outdoors, but indoors, kind of more aggressive environments that you might need. Typically you deploy this one on the ceiling, and again you can see that I have the options for external antennas. You can get it as a single band product. More commonly, and the picture shown here is a dual band product. How do I know it's dual band? Well, because it's got 6 antenna ports, so 3 of those would be used for the 2.4 gigahertz band and 3 of them would be used for transmissions and receptions in the 5 gigahertz band. So now we're looking at the Cisco Aranet 1260 series. Now this is also meant for a more rugged environment where you might have different types of temperatures and a little bit more attractive than you saw in the previous product. So a little bit more streamlined for an indoor environment like a factory, a warehouse, where maybe you do care a little bit about what it looks like. It's also got the external antennas, and so you can deploy it in more difficult environments where you may need to have coverage that internal antennas don't provide. It comes as a single band or dual band. It supports N as well as your legacy ABG, and so it's really a good access point for environments that need a more robust access point. Now we come to my favorite access point, the 3500 series. And this is a product, and you can see there it comes in 2 models. There is the one with internal antennas and the one with external antennas. And just like we've been seeing before, we have 3 antennas for the 2.4 gigahertz band and 3 antennas for the 5 gigahertz band. So the reason they're my favorite access point is that they include the Cisco Clean Air technology, which means that it can detect what's happening in the RF environment. It can then start to feed that back and start to optimize how it's performing in the RF environment by doing what they refer to in Cisco as self-healing and self-optimization in order to avoid that interference levels. Now, a couple of things you need to know about this access point. First, It only comes in lightweight mode. You cannot deploy it in an autonomous mode. And the reason is you'd buy this access point if you're working in difficult RF environments where it's really important that you're managing that interference and taking action to address that interference issues. If you're familiar with the Cisco Spectrum Expert, it's integrated that technology directly now into the access point. And so for that to operate, it needs to interwork with the wireless LAN controller. And it supports all of the security, etc., quality of service features that you'd expect of a high-end access point. So I wanted to tell you a little bit more about the clean air technology. Again, the 3500 and the 3600 access points support the clean air technologies. Clean air technology will actually detect 802.11 sources of interference like adjacent or neighboring wireless LANs that aren't part of the corporate network or rogue access points. But it actually also detects non-802.11 interferers. And so that would be things like cordless phones, Bluetooth devices, microwave ovens. And it detects them and records their name. Other access points, they will measure the interference, but they don't provide enough information such you can actually diagnose what is the cause of the interference. So the clean air technology takes it to the next level and actually identifies what those sources of interference are. Once you've detected what the source of interference is, you can then execute your policy against that. So that might be more proactive, or it may be more informative, just sending off alarms and sending reports, etc. So the last access point we want to talk about is the 3600. Now I do personally find this a little bit confusing. So Cisco will call this a 4x4 MIMO, but it only is actually transmitting 3 spatial streams when it talks about getting the higher data rates. So when you think about 4x4 MIMO, you tend to think about 600 megabits per second, but these antennas only create 3 different spatial streams, and so it gets up to 450, which is still a lot better than the previous access points, but it can be a little bit confusing because they do call it a 4x4 MIMO, and according to the standards, 4x4 MIMO would get you up to 600 megabits per second. So what this is doing is it's transmitting 3 spatial streams, and the 4th antenna, I suspect, is probably used for receiving or for some duplication. So it is still using the 4 antennas, but 3 spatial streams giving you a data rate of 450 megabits per second. Again, it comes in a single or a dual mode radio, and interestingly enough, this one is also apparently got a module expansion technique, which it will cater for the newer standard 802.11ac. And Cisco say that it promises, with that modular expansion, data rates up to 870 megabits per second. And as I mentioned earlier, this does support the clean air technology. So a few terms that you should be familiar with when we're talking about Cisco technology. We talked about the clean air technology. There's also the client link. And what client link is, on the access point, it uses the multiple antennas to create a beam, just like we talked about before, beam forming on the downlink, i.e. from the access point to the client, but not just for N, but for AG clients as well. And this is actually quite a good thing, because by putting beamforming on the downlink, you can potentially increase the data rates to legacy equipment. So instead of being able to transmit them, let's say, at 36 megabits per second, now you can transmit them at 48 megabits per second, because you're focusing that energy towards them on a beam. And again, it's only on the downlink, which is good because most of your traffic is normally on the downlink. Next, the band select. Now what band select does is it really helps the client connect to the 5 gigahertz band over preference on the 2.4 gigahertz band. And the way it does it is that if the client kind of probes in the 2.4, it kind of doesn't respond, and so it responds to the 5 gigahertz band probes. And so in this way, if a client doesn't see responses to his probe, then it's going to go ahead and connect to his 5 gigahertz band access point. So it kind of favors clients which are capable of transmitting in the 5 gigahertz band to move to the 5 gigahertz band. And our last one here is video stream. So video stream improves the performance when you're streaming video content, and that will be things like stream admissions and prioritization, resource reservations. Also includes some monitoring capabilities. So it's all about making sure the client which wants to do video has the resources that it needs, is being monitored such that the user has a good experience. And interestingly enough, if you're wondering what the multicast to unicast is, what that is it would take a multicast stream, and by the definition multicast data would be normally sent as a best effort, and it makes it a unicast, and by making it a unicast it can be given a higher priority than the best effort traffic and therefore improve your user experience. So that's why they have that multicast to unicast, so you can prioritize the unicast data stream. So we've talked about legacy access points, and we've talked about 802.11n access points. And I have more access points that we need to talk about. These last ones are deployed for bridge and outdoor mesh environments. So this first one is the IRINET 1300, and this access point has the capability of operating in a bridge mode and a workgroup bridge mode. Now notice that this access point is only a single band radio supporting just the B and G radio. It's hard to tell from this diagram, but it does have external antennas. The 1400, the same thing, but now supporting 802.11a, so it's up in the 5 gigahertz band. Now this product is now end of life, but again you may see it out there. So now we get to talk about my second favorite access point, the 1550 series. These are targeted for outdoor networks, and the 1550 actually includes the clean air technology and is considered to be not only enterprise but also carrier grade. And carrier grade is important if you ever get involved with 3G or 4G data offload, so your cellular networks offloaded onto a Wi-Fi network. It's obviously for outdoor deployment because of the rugged shell that it has, and it can be built as an external access point or a cable modem access point. There's a model for hazardous locations. Typically you deploy this with external antennas, but there is a model for internal antennas as well. And interestingly enough, if you ever come up for a need for it, the 1552S is actually an outdoor access point meant for sensor networks, and so you'd use that if you were working at a factory or a farm that's using a lot of sensors. Oil rigs would be another example, like temperature controls, light controls, etc. This is an access point that's been designed for that specific purpose. So in this demonstration I want to show you how I would have to manually configure my Cisco IRINET 1040 access point. Now I'd already gone in through the console port and given it a static IP address. Once I've given it a static IP address, then I can reconnect to it through the Ethernet port, and simply key in that IP address here. And in this case I gave it the IP address of 10.5.5.3, and so I've now brought up my web browser and connected to the access point. Now if I want to configure this quickly, I would go through the Express setups. Now before I do that, you always want to take a look at the system software. So let's take a look at the product that we have. Here it shows me the product number, and you can see it says AP, just like we talked about, which means this is an autonomous mode access point. It's not operating in a lightweight mode. Here you can see the software that I've got loaded and the version number that I'm currently running at. So assuming we're happy with the software and we don't want to reload that, we would then go through the Express setup. And there's two parts. There's the Express setup and then the Express security. So here is where I would give it a name. So I can just call this train signal. You can see here the static IP address that I gave it. I could change that at this point, or I could set it up to get an IP address from the network using DHCP. Notice here I've got two radios because this is a dual mode access point. I've got 2.4 and 5 gigahertz, and I can define the role for the 2.4 and the role for the 5 gigahertz. So here you can see I have it set up in access mode. Other modes are repeater, the bridge mode, the workgroup mode, and so again I can set it up depending on how I want this access point to function. And again, two radios, so I can set them up independently. This is where I can actually optimize the network for throughput or range. If I did it for throughput, what's going to happen is I'm going to not support the lower data rates, which means the range of the cell will be smaller, but my average data rate for the users will be higher. If I was to select range instead, what's going to happen is that will support the lower data rates, which means that I will have a much larger cell radius, all the way up to 1 megabit per second, but my average data rate therefore would be reduced. I can also select custom here. I'm going to lose my changes, but let me just show you. And here again, this is where I would come in and select here the data rates that I want to support. And again, if I don't support the lower data rates, it will reduce my range but improve my average throughput. If I come down further, I can set the power level. I can set the power level of the transmitter, so when my access point is transmitting, but I can also set the maximum level that a client can transmit. So say for instance I've got VoIP phones operating, I might choose here 11 dBm, and I've got the translation table over here if I want to go between milliwatts and dBm. Then I might want to set the client accordingly, because I don't want a client transmitting at a higher power level and causing more interference than it needs to. Here I can configure my channel, so let's say I want it on channel 6. I can just support my channel bandwidth, because remember that 802.11n supports 20 and 40 megahertz channels. If we come down a bit further, you can see here I can set some of the default parameters for how my access point is going to operate. Here's the period of how often I send out the beacon. This is my DTIM. This is how often I alert clients to the fact I have broadcast messages. The request to send retries and threshold is controlling the distributed coordination function, and here I set my threshold quite high, so any MAC frames above this threshold would have to do a request to send clear to send. Anything below this threshold would just go ahead and listen to the medium, and if it was clear for a period of time, it would then go ahead and transmit. Here you see my data retries, should I not get an acknowledgement back. And here's the fragmentation, so any frames bigger than this I would want to fragment into smaller chunks to send over the air. So let's just cancel out of this and go back to our Express setup. Okay, now because of the warning I didn't keep my host name, but that's fine. And you can come down therefore and see I could do exactly the same then for my 802.11 radio operating in the 5 gigahertz band. So once I've done the Express setup, I would then do the Express security setup. And here's my opportunity to say, oh, now I want to give it an SSID. So I can say, train signal. And over here I can say I want to include the SSID in the beacon. This is where I would set up a VLAN ID if I wanted to make sure I was mapping correctly to a right VLAN. And you'd certainly want to do that if you were setting up multiple SSIDs. Here I can set up my security. Of course, we always recommend WPA. And here, if I was using an external radio server, I can set that up here too. So I can choose WPA, but if I want to have more advanced security here, I would choose EAP. And again, this is enabling me now to use 802.1x, which is what I'd want to use in a corporate environment, and it supports a range of different EAP methods. So then I'm done. The problem is, well, what if I want to do something else? And let me show you how difficult that can be. So here's my network interfaces. This is where I'd configure my wireline settings. Here's my IP address, etc., default gateway. Here's my Ethernet connection to the network, and here are my two radio connections here. So I can click on this, or I can click on this, and then we can go in and configure the radio. So if I click here, and what I want to do is I want to go into settings. And here you can see I can enable the radio. I obviously have to enable it in order for it to start transmitting. Again, I can talk about the role of the access point. Here you can see I can set the data rates just like we talked about in the channel. Here I can set up the beacon times just like we did before. And again, I would do that for both radios. I got here the more advanced security features. So perhaps I want to set here, click on this, the SSIDs, and if you scroll down here, you will see that this is where I have the ability to set up additional SSIDs. So you can see I can set up a guest SSID, and I can distinguish between the 2.4 and the 5 gigahertz mode. So you see, the minute I want to do something like guest authentication, manipulate the data rates, setting up the configuration in the access point in an autonomous mode actually becomes a little bit painful and time-consuming. And you can see some of the other advanced features that I might want to use here as well. So I hope this demonstration has given you a feel for what it takes to program an autonomous access point, and it's not the easiest thing. And although the Express setup can get me up really quickly, as soon as I want to do something like changing the authentication or setting up VLANs, then I have to go into the sub menus. And in my personal opinion, if you get above about 3 to 5 access points, I would personally put in a wireless LAN controller and drive my configurations down from the controller rather than doing this for 3 to 5 access points. And you could see, especially if you're under pressure of time, you could easily configure something wrong. Or for instance, if I want to go in and tweak the power level, I've got to find what sub-menu it is, tweak the power down, take a look at what's happening on the RF side. Whereas if I'm using a wireless LAN controller, especially one and access points that support the clean air technology, I can actually do it much quicker just by supporting it at the wireless LAN controller. So my personal preference, anything above 3 or 5 access points, I like to go to a wireless LAN controller, and my strong preference is for the clean air technologies, simply because it makes the management of the RF so much easier. But of course you are introducing the cost of more expensive access points, and you are paying the cost of a wireless LAN controller. I hope you found this of value.